Okay, so to work out this antiderivative, we're going to use substitution and let u equal, well, the most natural thing to do would be to let it equal this function inside the square root. So that's 1 minus x squared. So then computing the differential du, we get negative 2x dx. Now, there is an x dx, which this is right here, I'm looking at x dx, sitting inside this integrand. It's kind of like there's a dx, and one of these three x's would stand in for the x that's here. And so we're going to go ahead and rewrite it as negative 1/2 du is equal to x dx. And so we can split up this x cubed as x squared times x, and I'll go ahead and do that. X squared, right? And so we can see that this x dx piece, which is here, can be replaced by negative 1/2 du. So we can start rewriting a lot of this integrand here as, okay, the denominator is square root of, you can see square root of 1 minus x squared, which is here, we're going to write it as square root of u. And then this x dx piece, which is here, we're going to write it as negative 1/2 du. And I'll pull out the negative 1/2. And there's my du. And now what we have to deal with is this numerator leftover piece, because we've kind of taken care of the denominator. We've taken care of x dx, and we have this x squared is left over. So how do I deal with that? We got to get everything in our integrand in terms of u. And we can't have this x squared just hanging out there like that. So if you look at the substitution we're using, you can actually solve for x squared. And you're going to get, basically, let me do a little switch around here. We can have the x squared over here. We can bring this u over here. And so you have that x squared is equal to 1 minus u. And so we can replace this x squared piece, which would be in the numerator here, with, so x squared is 1 minus u. All right. Now, this leads us to this integrand. And we can actually change everything into like powers of u. And so I'm going to have 1 minus u over u to the 1/2. And you can kind of distribute this u to the 1/2 to the 1. So you 1 over u to the 1/2, and you have u over u to the 1/2. And so that's going to simplify. Let me scooch it up and over. We're going to get minus 1/2 integral of u to the negative 1/2, right? And that comes from rewriting 1 over u to the 1/2 as a power of u, minus, and then what is u to the u over u to the 1/2, and that ends up being u to the positive 1/2, because those powers subtract, and then you have your du. So this this integral is now just the power law, right? Because these powers here, fractional powers, we can just use the power law on that. So working it out, we're going to get negative 1/2. And the way I like to work this out, so you got a big parentheses, u to the 1/2, or u to the negative 1/2, what do? We add the power. So we're going to add the power to negative 1/2. We add 1, and we get positive 1/2, and you divide by a positive 1/2, which is the same as multiplying by 2. And then bring down the minus, and then you have u to the And to this 1/2, we add 1. That gives us 3/2, and then we divide by 3/2, which is the same as multiplying by 2/3. Okay, and so that's how you work that out. And notice here, there's no integral. This integral sign, you drop it when you actually compute the integral. And so from this stage, this is all the like pre-calculus stuff. Here we're going to use some algebra to make it look prettier, and also to simplify. And so we have negative u to the 1/2 minus, and then here you can see negative 1/2 times 2/3. The 2 and the 2, they kind of cancel. And then this negative and negative, that makes that a positive 2. Oh, sorry, not 2. Whoops, eraser. 1/3 u to the 3/2 plus c. Okay, because I've just distributed that multiple. And then finally, resubstitute. Notice here, our u, let's go back here. I'm going to rewrite. Our u is 1 minus x squared. So we're just going to replace the u's here and here with 1 minus x squared. And so we're going to have negative square root of 1 minus x squared plus 1/3 times 1 minus x squared to the 3/2 plus c, and we're done.